Hello again, everyone. Welcome to our discussion of section 7.4, where we will be talking about solving nonlinear systems. As you recall, systems means two or more equations solved together at the same time to see if they intersect each other at one or more points. We did that with two equations, two linear equations with two unknowns. We did that last time also with three linear equations and three unknowns. But those were linear equations. That means the x and y variables had power 1. There were no square roots or there were no rational expressions either. So everything was linear. But in this section, we will talk about solving systems that have variables to powers higher than 1. Those same methods work. Those same methods we discussed, which were method of elimination and substitution, work, but the graphs of such systems will be a little bit different than that. Before we begin and talk about the details of this section, I want to remind you to please read through or skim through section 7.4 in your book, and then before watching this video or attending class, and then attend class and watch the video and take notes, detailed notes about any questions you might have, anything you might see or hear that might seem important to you. And then please revisit the book and this video and redo all the example problems that you see solved in the book or in this video without looking at the solutions. As I mentioned before, preferably even when you do this with the video the first time, when you watch the video for the first time, it's preferable that you pause the video and come up with your own solution given the explanations given before solving any example. And then please remember to complete all the homework assignments by the due date, and of course review all the previous material, because mathematics is a cumulative subject and quite frequently we use the skills and techniques we've learned before to solve current problems. Okay? All right, so as we said, these are nonlinear systems, and they are systems, so you can see an example of it right there on the screen, where you have two equations, but in one of those equations you have x and y squared, right? X squared plus y squared. So these are the first equation, not the second. The first equation at the top tells you that this is a nonlinear system. So how do we solve nonlinear system? It's the same methods we discussed before. Method of substitution. The same substitution and elimination method that we've discussed before are also applicable here. You can pick whichever one that seems easier to you to apply and use that. You will surely get the same answer as somebody who used the other one. If you use substitution, you should get the same answer as I do if I use elimination method. It makes no difference. For example, in this case, what I want to do is solve for variable y, let's say. You can solve for variable x, it makes no difference. I'll solve for variable y from the bottom equation. Negative x is on the left. When I move it to the right, it becomes positive, right? So x, positive x plus 2. So now I've solved for y in terms of x. Now I'm going to substitute for y in the top equation with this result. So using x squared plus y squared equals 100. Let's substitute for y with this quantity. So we have x squared plus all of that, x plus 2 squared, right? Y squared became x plus 2 squared because y is equal to x plus 2 equals 100. And now we need to expand this, right? In order to solve for x and then solve for y, we need to expand this. So let's do that. As I've asked you before, if you remember the special product formulas, do you remember what the three special products formulas were? The ones that I asked you to memorize? Let me write them again. A plus b squared is equal to the first term squared plus twice the first term times the second term plus the second term squared. That's one of the special product formulas with minus in between. You have the same things, but the middle term, instead of being positive 2ab, it's going to be minus 2ab plus b squared. And of course, the other one, the other special product formula is x plus y times x minus y, right? The product of the same two terms being added and subtracted, their product is equal to the first term squared minus the second term squared. These three special products are more important than the other two or three that I have not written down. Okay, so please make sure that you remember these as you go through these math classes. They become handy a lot. All right, so let's apply one of those special products here. If you don't remember them, then you have to FOIL this. So x squared plus 2 times the first term times the second term, we get 4x plus the second term squared, which is 4, right? 2 squared is 4, equals 100. Okay, so this is a quadratic equation. Let's move everything to one side and set it equal to 0 to solve for x. So we have 2x squared, right? X squared plus x squared is 2x squared plus 4x. And then we have 4 minus 100, right? Plus 4. Move the 100 to the left. It was positive on the right. When you move it, it becomes minus 100 equals 0. Then let's combine these two. 2x squared plus 4x minus 96 equals 0. So we have to solve this quadratic equation. We can apply the quadratic formula, but we might be able to simplify this and factor it more quickly. So let's factor the 2 out first, right? 2 can be factored out in this situation. So factoring the 2 out, we get x squared, right? 2 times x squared is 2x squared. So inside the parentheses, I must have terms such that when I multiply it by 2, I get that term back. So what should I put here so that when I multiply it by 2, I get 4x back plus 2x, right? 2 times 2x is 4x. Then minus, what should I put here so that when I multiply it by 2, I get 96? Well, these are easy numbers, so 48 should do it, right? Equals 0. Now, the other side is 0. This side has a factor. We can divide both sides by 2. What happens on the left is that these 2's cancel each other out because this is being multiplied, not added. This 2 is being multiplied, so it can get canceled with the 2 in the denominator. On the right, anything 0 divided by anything is 0, right? So we get this equation. We get x squared plus 2x minus 48 equals 0. Now, this is an easy quadratic equation to factor, right? It's what two numbers multiply to negative 48 and add up to positive 2x. X plus 8 times x minus 6. Right? So x times x is x squared. 8 times minus 6 minus 48. Where is the 2x coming from? The 2x is coming from the adding of the x terms. Where are the x terms coming from? X times minus 6 is minus 6x plus 8 times x, which is 8x. 8x minus 6x is 2x, positive 2x. Okay, so we have the positive or factors. So let's solve for the x values. So x plus 8 equals to 0, then x equals minus 8, and x minus 6 equals to 0, then x equals 6, positive 6. Okay, so we've solved for x. Now we need to solve for y, right? Remember that. Remember y is x plus 2. Remember that? We got that from the bottom equation. Y equals x plus 2. So let's use that. So using y equals x plus 2, we have if x equals minus 8, then y equals minus 8 plus 2, and y equals minus 6. Therefore, one of the solutions of the system is x equals minus 8, comma, y equals minus 6. That's one of the solutions of the system. Okay, for x equals minus 8, the y is equal to minus 6. Now, if x equals 6, right, then y is equal to 6 plus 2, and therefore y equals 8. Therefore, the second solution to this system is x equals 6, comma, y equals 8. That's the second solution. So those two lines or curves in the system intersect each other at these 2 points. Okay. Once we finish these, there are 2 more examples. Once I finish the other 2 examples of this category, I'm going to go to the computer and we're going to plot these. Okay. Or maybe I should do it at the very end. Yes, I'll do it at the very end, because the reason for that is because as I graph these, as I switch from the dock camera to the computer, the dock camera shuts down, and it takes a while to get it back up again. So let's graph these systems at the very end. That way we don't have to worry about the dock camera turning itself off. Okay, we'll do that. But I want you guys to see the graphs of these systems. They are very, very interesting, and they shed light on how these systems, the solutions of these systems, what they mean, actually. Okay, so here's another system. If you haven't done this already, please pause the video. Solve this according to what you saw me do on the previous example, and then come back to the video to see if your solution matches what I have. Okay, so I'm assuming you've done that, and now you're back. Okay, so what we can do is, in this case, for example, we can, just like before, solve for one of these variables, and then substitute in the other equation and solve for the other variable and plug back in again. So let's do that. Here we can use this one, or we can use this one actually. Let's use the bottom equation, that one, to solve for y squared. So y squared is equal to, move the 4x squared to the other side. So we have minus 4x squared, right? When we move 4x squared from left to the right, it changes algebraic sign to its opposite. It was positive, now it's negative. plus 4, which was already on that side, right? So y squared is equal to that. Now let's substitute for y squared in the top equation. Okay, so using y squared minus 4x squared equals 4, we have, I'm going to substitute all of this for y squared. Minus 4x squared plus 4, right? That's just y squared, like that. Minus 4x squared equals, well, let's see, y squared minus 4x squared equals 4, right? Like that. So the y squared is gone. Instead, we have this, the equivalent of y squared. What does this do? It reduces that equation from an equation with 2 variables to an equation with 1 variable, for which we can solve for x. Okay, so this minus after the parenthesis is just neutral. So let's remove the parentheses and combine the x squared terms. So we have minus 4x squared plus 4 minus 4x squared. And so we have, let's see, in this case, what do we have? We have equals 4. Minus 4x squared plus, I want to double check this to make sure that I'm on the right path here. It looks like it. And then minus, yeah, that's okay. So then we have, let's combine the x squared terms. We have minus 8x squared equals, move this 4 to the other side. We have 4 minus 4. And from here, we have minus 8x squared equals 0. Therefore, x equals 0. Okay, so that's the value of x. Let's plug this into the original any of the original equations and solve for the y. So I'm going to use the bottom equation. So using 4x squared plus y squared equals 4, and substitute for x with 0. So 4 times 0 squared plus y squared equals 4. We have 0 here, 0 plus y squared. We have y squared equals 4, and therefore y is equal to, take the square root of both sides, right? So take the square root of, well, let me do that. Square root of y squared, square root of 4. Is this correct? What do you think? Is this correct, or is it missing something? It's missing something. What is it? Do you remember? Well, remember that if we take the square root of both sides, the constant side must always be plus or minus, unless this number, constant, represents some kind of a distance, say the radius of a circle or the distance between 2 points. If it represents a distance, then we accept just the positive and we discount or disregard the negative, only if that number represents a distance. But in this case, it does not represent a distance. So we have y equals plus or minus 2. Okay, so the solution for this system then is x equals 0 comma positive 2 and x equals 0 comma negative 2. Okay, those are the solutions of that system. Okay, we will graph that soon enough. Here's another example. So please go ahead, pause the video, solve this problem, and then come back to the video when you have your solution completed. Okay, that is a huge part of learning this content. Please do not skip it. Okay, please write down your own solution. All right, so I'm assuming you've done that and now you're back to the video. I'm going to use the method of substitution again. So from the bottom equation, I'm going to solve for one of these variables. It makes no difference for which one we solve. Let's solve for x. So x is equal to 4 divided by y, right? Like that. Now I'm going to plug in the top equation for wherever I see x, I'm going to plug 4 over y. So right there, now we have using x squared plus 4y squared equals 20. We have the following. 4 over y squared, right? Instead of x squared, we have 4 over y squared plus 4y squared equals 20. So what do we have? We have the square this. We have 16 over y squared plus 4y squared, and let's move the negative 20 to the left and set it equal to 0, because this is beginning to look like a quadratic equation. So minus 20, right? Bring this to the left. It becomes minus because it was positive on the right, equals 0. What would you do next? Or what have you done next in your own solution? Well, let's take the common denominator. The common denominator in this case is y squared, right? So y squared is the common denominator. Now, compare this, and the denominator here is 1. The denominator here is 1, right? Compare this common denominator with this denominator. Is there anything missing? No, it's not missing. So this 16, we can write it without doing anything to it. We don't have to multiply the numerator and the denominator by anything because the denominators match. Now, compare this with this. Is there anything missing? Yes, y squared is missing, right? So multiply the numerator, which is 4y squared, by the missing part from the common denominator. So y squared times 4y squared plus 4y squared times y squared. Okay, so I multiplied 4y squared by what was missing from its denominator when compared to the common denominator, which is y squared. Then minus 20 times, once again, y squared is missing from the denominator. So multiply minus 20 by the missing piece, y squared, equals 0. Okay, so let's simplify this. We have 16 plus 4y to the 4th power minus 20y squared divided by y squared equals 0. Okay. So now, let's get rid of this denominator by multiplying both sides by y squared. So y squared times 16 plus 4y to the 4th minus 20y squared over y squared equals y squared times 0. Let me move up here to continue with this solution. Like that. Okay, so on the left, the y squared and y squared cancel out. We end up with, let's put this in order. We end up with 4y to the 4th minus 20y squared plus 16 equals 0. I just simplified on both sides. And I put this in order of descending order of powers of y. Okay? So y to the 4th, y squared, and that. So Do you remember what method we used to effectively solve equations like this? Do you remember what that method is called? That's why I keep asking you guys to review the previous material, because it'll keep all that stuff fresh in your mind. Well, we use the U substitution method, right? We're going to use that again, but before that, let's factor the 4 out, because we can simplify this equation a bit by factoring out the 4. They all have common factor 4, right? So factoring out the 4, we have 4 y to the 4th. What should I put here to multiply by 4 to obtain 20y squared? Well, 5y squared, right? 4 times minus 5y squared is minus 20y squared. What should I put here to multiply by 4 to get positive 16? Well, 4, right? 4 equals 0. So once again, let's divide both sides by 4, like that. So on the left, the 4's cancel out. We end up with y to the 4th minus 5y squared plus 4 equals 0. Right? So now let's use the U substitution method. So let U be y squared. So we're going to end up with, if U equals y squared, then y to the 4th is U squared minus 5u plus 4 equals 0. Well, this is a very easy equation to factor, right? So U minus 4 times U minus 1 equals 0. U minus 4 equals 0, that means U equals 4. And U minus 1 equals 0, that means U equals 1. Okay, so are we done? No. We just found the values of U. So we need to find values of y squared. So if, and then of course find the values of x as well. So I'm running out of space again, but I'll try to continue in this corner. So if U minus, if U equals 4, right, then substitute here. Let me box this and put an arrow here. That's what we're doing here. If in this equation, if U equals 4, then y squared equals 4, then y equals plus or minus 2, right? If U equals 1, like that, then y squared equals 1, then y equals plus or minus 1. Okay? So we found the values of 4 values of y, plus or minus 1, plus or minus 2. So now we need to find the values of x. Let's find that. So x is equal to 4 over y. Remember that? Remember what we started with? X equals 4 over y. So we'll use this relationship to find the values of x. So therefore, let me just summarize it here. Then plug in positive 2. What do you get? 4 divided by positive 2, 2. So for when y is equal to positive 2, then x equals 2. So that's one of the points. That's one of the solutions. When y equals minus 2, then x equals minus 2 as well. So minus 2 comma minus 2, that's another solution. When y equals plus 1, then x is equal to 4, positive 4 comma 1. That's another solution. And of course, when y equals negative 1, then x equals minus 4. So minus 4 minus 1 is another solution. Okay. Oops, I was off the screen there for a second. So those 4 solutions belong to that system we started with, which means those 2 lines or curves intersect each other at these 4 points. Okay. So everything we did so far, these were nonlinear systems of equalities. But now we get to nonlinear systems of inequalities. Okay, these are inequalities. Now, the solutions of nonlinear systems of inequality, generally speaking, inequalities usually have infinitely many solutions. So how do you capture infinitely many solutions? Well, you graph them. You show the solution using a graph rather than using some kind of an interval. Usually that's how it's done when you have infinitely many solutions on a plane, which is this is going to be, okay, because it's on an XY plane. So even though, so basically some of these are easier than others to plot. I'm going to roughly plot these, and then we're going to go to the computer. And at the very end, we'll do that. Okay? So this x squared plus y squared less than or equal to 10, this is a this is a circle of radius square root of 10. So square root of 10, whatever that is, let's see what if I can find my calculator here. This is a typical equation of a circle. If you don't know that, that's fine, but those of you who will be taking trigonometry or 127, math 127, you will become very familiar with that. Okay? So, but that's the equation of a circle. But of course, this is an inequality, meaning that all the points inside and on the perimeter of the circle are the solution. Anything outside of the circle is not a solution. See, x squared plus y squared less than or equal to 10. So I wanted to take the square root of 10 to have an idea. It must be 3 point something, right? So let's see, square root of 10. Let's say 3.2, right? 3.2 radius. So this is a circle of a circle of radius almost 3.2. Okay. Another thing I should mention about the whole thing, that refers to the inside of that circle, because everything is less than or equal to the radius. So the inside of a circle of radius 3.2 is the graph of that. And of course, y equals x is, or because we need to find, to graph each of these inequalities, first you must find the boundary. So y equals x is the line that goes through the origin, that dissects. I'm going to put a dashed line here, like that. That's roughly the equation of y equals x, but this is y greater than x. So it'll be that way. It will be this side of the line. Not on the line, because y is not equal to x. So it'll be all the points on that side of this line. Okay? That's the side of this line that should get shaded, y greater than or equal to x. Okay? All right. So now the circle of radius 3.2, let's say 1, 2, 3, this is 4, this is 3, so 3.2 is somewhere there, and 1, 2, 3, so let's say here, here, and then 1, 2, 3, and of course the center of this circle is at the origin, 2, 3, and like that. So if I try to roughly sketch this circle, so if I come this way, go through it like that, I know my drawing is not very look like a circle, but I tried here, like that. Then that is referring to the inside of a circle and to the left of this line. So this is the solution region. The region that I've shaded is the solution region. It's where those two curves, the solution for each inequality overlaps. If you go beyond the circle, outside of the circle, that's not the solution of the system because it's going to be outside of the circle. But outside of the circle, you have this line. But it's not the solution of the system. So what I have shaded is where both solutions overlap, which is what you want. Okay? So that's roughly the solution of this system. Again, we will go to the computer to see a nice graph of all of this. So this is, once again, it's an equation of, if you disregard the inequality, this is the equation of a circle of radius 3, because that side is always r squared. So r must have been 3. But this one, look at the inequality symbol. It's referring to everything outside of the circle. On the circle, all the points that are on the circle equal to 9, right? On the circle and beyond the circle are the solutions. So if we draw a circle of radius 3, let's say like that, and this is outside of that radius, so that's what it's talking about, outside of that. On the circle or outside of the circle is the solution for that top inequality. And this one, of course, is, that one is, so let me write down here, a radius or circle of radius 3, and let me add all the points on the circle or outside of the circle. Okay, that's the solution of that one. Now this one, it's a line, right? So x minus 1 equals to 3, or we can solve this for y. It'll be y equals x minus 3. That's that line. And the intercepts are, so if, let's find the intercepts. If x equals 0, then y equals minus 3. If y equals to 0, then we have x equals 3. Okay, so intercepts are, the intercepts are 0, negative 3, and 3, 0. So let's plot this line as well. 0, negative 3 would be here. Not there, here. This is 0, negative 3, 0, negative 3, and 3, 0, so that's the point, not that. And then 3, 0, which is that. Okay? If we connect And no point on the line is accepted because this is a strict inequality. So I'm going to draw a dashed line through those 2 points. Now, which side of that line is the solution? Well, let's pick a test point. So if we, test testing x minus y greater than 3, right? So let's pick a test point on this side of the line, safely on this side of the line. Let's pick that point, 5, 0, and see if it's valid. So plug in testing 5, 0. We have 5 minus 0 greater than 3, 5 greater than 3. Is that a valid statement? Yes. So that side of the line is the solution, that side. All of that is the solution. So any portion of the graph that is on this side of the line and outside of the circle, not inside of the circle, outside of the circle is a solution. In other words, the solution of that system of inequality, that one, is this. Is here, and then also, and then I'm going to draw this as a dashed line because that line is not part of the solution. And then all of those points. So that's the solution of that system of inequality. Okay? Not these regions, not these regions, because those regions are that way. We want the overlapping section to be the solution region, and that this piece, maybe I should make it darker, a little bit darker. So that's what the solution of this region is. Outside of the circle, not inside. Okay. That's where the solutions overlap. Okay, so that's the solution of that system. All right. So before we go to the computer, here's a word problem. Let's solve that. That way, once we go to the graphing tool, the computer, then we'll be fine. The dark camera can shut off, and we won't mind that. All right, so because so far we've done plenty of word problems, so I highly encourage you to solve this problem on your own, and then, so pause the video, solve this word problem on your own, and then come back to the video. The only hint I would give you is draw a picture. Let a picture help you, okay? All right, so I'm assuming you've already done that, and now you're back with your solution already on the paper. All right, so it says, Allison's Advertising is building a rectangular sign with an area of 2 yards squared and a perimeter of 6 yards, okay? So this is a rectangular sign. Let's draw a picture. Here we have a rectangular sign, maybe a billboard of some kind. And we know that the area is 2 yards squared, okay, and a perimeter of 6 yards. So if we label this as length and this as width, the perimeter being 6 yards, what does that mean? That means, so notice how I introduced variables. That's we need to do that whenever we solve word problems, right? So length, width. Now they say the area is that much, and so what is the area from elementary geometry? What is the area of a rectangle? How do we calculate? What's the formula for the area of a rectangle? Do you remember? So from elementary geometry, the area of a rectangle is equal to width times the length. Remember that? Then they also say that a perimeter of 6 yards, okay, what's the, from elementary geometry, what is the formula for the perimeter of a rectangle? Well, it is perimeter is equal to 2L plus 2W. Remember that? That's the basic formula for the perimeter of a rectangle. 2L, L plus 2W, W plus W. Right? That would be the perimeter. Okay, so now we know that the area was 2 yards squared. So we know that 2 yards squared is W times L, right? And then the perimeter is 6 yards. So we can say that 6 equals 2L plus 2W. Find the dimensions of the sign. Well, this is a system, right? We have a system of two equations, two unknowns. We easily can solve this, right? So this is a system of 2 equals WL and 6 equals 2L plus 2W. From the top equation, we can solve for one of the variables. Let's say to solve for L. So we get 2 divided by W, right? Then plug that in this equation. So 6 equals 2 times, instead of L, plug in 2 over W plus 2W. So this nice substitution helped us reduce this equation that had 2 unknowns to an equation that has only 1 unknown, right? And we can easily solve this. So we have 6 equals 4 over W plus 2W. And nobody likes fractions, so let's clear the fraction by multiplying both sides by W, right? So W times 6 equals W times the entire right side, which is 4 over W plus 2W. Okay, so let's distribute and simplify. Let's first distribute. So on the left we have 6W, right? 6W. On the right, what do we have? We have W. I'm going to distribute but not simplify yet. W times 4W over W plus W times 2W. Now let's simplify. What do we get? We get 6W equals, the W's and cancel out here, 4 plus 2W squared. All right, this is a quadratic equality, right? So let's move everything to one side and set it equal to 0. I'm going to use 6W to the same side as these two guys. So those two are not going to move. So they're going to stay the same. They're going to have the same sign. So 2W squared plus 4, I'm moving this. It was positive, so it becomes minus 6W equals 0. Okay. Let's factor out 2 because 2 is a common factor here. All right, so this is like that. So factoring the 2 out, we get 2W squared plus 2 minus 3W equals 0, right? If you distribute the 2 into this, you get this back, 2W squared plus 4 minus 6W. So this is okay. Now let's divide both sides by 2. 2 and 2 cancel out. On the left, we get W squared. Let's put these in order. Minus 3W plus 2 equals 0, right? This is a very easy quadratic equation to factor. So w minus 1 times w minus 2 equals 0. So w minus 1 equals to 0, then the width must be equal to 1. W minus 2 equals 0, then w must be equals to 2. Okay? So we have two valid width regions here, or width measures here. Now let's find the, let's see, let's plug back into this equation here, right? So whichever one that makes sense, we'll accept that. So if you plug in 1, you get length equals 2. But if you plug in 2, you get length equals 1. So length is supposed to be longer than the width. That's by definition. So 2, if you plug in 2, it makes no sense. The length is going to be shorter than the width. So disregard this solution. Disregard this measure of width. Accept that one. So W equals 1 and length equals 2. 1 yard for the width and 2 yards for the length. Okay? It makes no difference really, because if you accepted that answer, you would get still the same thing, but width would be 2 and length is 1. It's just, I just picked the one, so the overall dimension of the sign would not make any difference, but what we call it would make a difference, right? Which one is the length and which one is the width, that's all. Okay, so I hope that this was, after all the work problems that we've done, this was an easy exercise. But now we want to go back and graph all these systems. In other words, we're going to go and graph this system. Okay, I'm just going to show you what we're going to go back and graph. So that I will post all these worksheet solutions on Canvas in addition to the video. So you will have this posted as well. But we're going to graph this system of inequalities. We're going to graph this system of inequalities, that one, remember this? That one. We're going to graph that system of equalities, nonlinear equalities. We're going to also graph that. And we're going to look at the intercepts. Where those curves intersect each other, we're going to look at that on the computer. We're going to look at that. And then we're going to look at this system, right? We're going to look at that system, and we're going to look at these intercepts where they intersect. These two. Okay. And also, we're going to graph this system. Okay. We solved this system and we ended up with these two solutions, right? We're going to look on the computer at all of these. Okay. As I switch, you know this, as I switch from the dock camera to the computer, your screen is going to blank out. So please ignore that. Everything is fine. And so let me do that now. Here we are, we're switching. Okay, now we're back. All right, so let's graph that first system of equalities on page 1 of the worksheet. We had x squared plus y squared equals 100. So this is I need to zoom out because this is a circle of radius 10, as you can see. Okay, So that's that. What you see on the screen is a plot of, look at the left side of your screen, left side at the top. That's the equation that plots into that. So this is a circle of radius 10 centered at the origin. Now let's plot the line. Y minus x equals 2. And there's the line. So what we found out in our calculations, that these two, the line and the circle, intersect at each other at 2 points. One of those points is -8, comma, -6. Look at that. Do you see the green dot? Let me snap to it. I don't know how visible it is in the video until I go home and look at the video. But that's where that intersection was. We found the solution of this system, which means we found where this circle and this line intersect each other. And that's one of the 2 points that we found. The other point we found was 6, comma, 8. And there you are. We can snap to it right there. The purple point. So those 2 points we were able to correctly calculate. Okay, so that's what the solution means. I wanted you to see the graph so you are familiar with the interpretation of these solutions that we have. Okay, those 2 points that we found are where the circle and the lines intersect each other. And this is a system of nonlinear equalities. And we'll get to inequalities later as well. All right, so let's go to the next system. Let's graph the next problem we had. We had y squared minus 4x squared equals 4. And so this is not a circle, right? How do we know? Because this middle sign is not positive, it's minus. See, when I change it to plus, in this case, it becomes an ellipse. Okay, so that's an ellipse. And then, so let's go back to minus equals 4. And then we had another curve that was 4x squared plus y squared equals 4. Okay, look at that. Maybe I should zoom in. This is better. So we have, what do we have here? We have a parabola or a hyperbola with a, we have a hyperbola and that at a juncture that is touching the main or major axis of an ellipse. And in trigonometry, you become more familiar with these concepts, the major axis of an ellipse and so on. But the major axis of an ellipse is the longer axis. Okay, the shorter axis is along the x-axis in this case. The major axis is along the y-axis. So at the ends of the major axis, the ellipse connects with a hyperbola. Okay, and we found those intersection points, right? One of them was at 0, 2, right there, the blue dot that you see, or the blue point. The other one was at 0, -2, and the green dot that you see there. Okay, so we identified those 2 intersection points between the 2 curves. Okay, so do you see what those solutions mean? We have nonlinear systems give us these curves, and these curves at some points intersect each other, as we found, and those points that we were finding are the points at which these curves, the ellipse and the hyperbola in this example, are intersecting each other. Okay, maybe I should zoom in a little more, like that. Like that. Okay, very cool, isn't it? Okay, so that's what it means to find the solutions of these systems. We have another system of nonlinear equalities. Let's also graph that. We have x squared plus 4y squared equals 20. Okay, so let me zoom out. So we have an ellipse, and in this case, the major axis of the ellipse, or the longer axis, lies along the x-axis, and the minor axis of the ellipse, or the shorter axis, lies along the y-axis. Okay, so that's that. So now let's plot the other curve, which was xy equals 4. Here we have another hyperbola, right? We have, it's like that. So let's like that. So let me, I think this is enough for zooming out. So that's that. So look at these curves. They are intersecting each other at 4 points, right? When we solved the system, we found 4 intersection points. Let's plot those points on the curves. So we found 2, 2, right there, the red dot. Let's label them. Then we found -2, -2. There it is, the blue point right there. And I don't know, maybe I should zoom in. Yeah, that's better, like this. You see that? So those curves are intersecting at those points. Then we found -4, -1, right there, the green point right there. And of course, we found another one which was +4, 1, which is that point on that side. Okay? So here we have 2 such curves that intersect each other at 4 points. So when we were solving the system of nonlinear equalities, we were looking for these intersection points. Okay? All right. Of course, these things have many applications in different areas: mechanical engineering, astrophysics, all of this, and other fields of science. So, all right. So now let's graph the nonlinear inequalities that we graph. Remember those? So we're gonna graph those. This is starting page 3 of the worksheet. We had the x squared. Remember, these are inequalities, so we're going to have a lot of color here. It's going to be a whole sections of the plane that is going to be the solution of the system. With inequalities, we always have that. So we have that less than or equal to 10. So that's a circle. And that's a circle of radius about 3.2. Remember that? Remember when we were, well, that's too close. Maybe I should zoom out like this. So so that's a radius of about 3.2. We got that. Then we had this line, y greater than x, like that. So, of course, the computer doesn't know what we're looking for, so it's just going to shade all the regions for this line, y greater than x. Okay? It's us. We know what we're looking for, right? The computer doesn't know what we're looking for. The computer is just graphing these inequalities individually. But you know and I know that the solution of this system of nonlinear inequalities is wherever these solutions overlap. Okay? Which, as you recall, on the paper, we shaded this region inside the circle. That's where they overlap. Both solutions overlap in this half of the circle on the inside. Okay? With the line being dashed because any points on the line are not part of the solution. Okay? They're part of the circle, but not part of the solution of the system. The system is the overlapping regions only. Okay? So that's the graph of that. So do you see why with nonlinear in system of inequalities we don't have individual solutions? Because we have infinitely many solutions. I mean, inside that circle, between the line and that circumference of this circle, you have infinitely many solutions. So you're not going to be able to list them. That's why we use graphing technology to show the graph where the solution is. Okay, let's look at that last linear or nonlinear inequality that we solved. So that one was x squared plus y squared greater than or equal to 9, right? Notice that as soon as I hit enter, the computer graphed or splashed color all over the outside of the circle, because the outside of the circle is where the solution is, all the way towards infinity. So we can zoom out, and you see that? The blue region extends to infinity. It's anything outside of the circle that is the solution, not inside. The inside of the circle is not the solution. It's outside. And you can see it from this inequality symbol here. Look, take a look at this inequality symbol in the upper left corner. It's greater than or equal to 9, right? So any point on the circumference of the circle and outside of it, greater than 9, all those points are the solution of this nonlinear inequality. But, of course, this is a system. So we need to see where there is overlap with this curve or line, with this line, like that. See? So we have, let me scroll this over. We have the overlap outside of the circle and outside of this, or to the bottom side or right side of this line. Okay? Remember the graph that we had? When I post the graph on Canvas, compare this with what we had, right? So the solution is right outside, on the right side of this dashed line and outside of this side of the circle, this side. Okay, outside of that circle, not on the inside of the circle. On the inside of the circle, part of it, there is a solution for the line, but not circle. Okay, it's only outside of the circle and on the right side of this dashed line where we have the overlap. Okay, all right, so that's the graph of these solution regions, and I hope it made things more understandable. If there were any vague points, I hope this video cleared all of those. So thank you again for persisting through this video and watching it from beginning to the end. And for now, have a nice day, and I'll see you again next time.